Well, student, welcome to my video on uh, the chapter Units and Measurement, where I'll be discussing about the topic accuracy and precision and errors in a measurement today. So first let us see what do you mean by accuracy and precision. Now we are very much well acquainted with the term accuracy. The term accuracy means the closeness of a measurement to the true value of a physical quantity. That is, it is the closeness of a measurement to the true value. That is how near you are to the true value of the physical quantity. Suppose the measurement of a length is accurately is 1.5 meter, and with the help of the scale you are measuring, you are able to measure accurately up to 1.49 meter. That means your accuracy is up to 1.59. That is, you are very much near to the physical quantity's true value, but not exactly. So that is your accuracy, how accurate you are to the actual value. And precision means reduction of the limit to which the quantity is measured. Okay, that means I mean not reduction, it is refers to the resolution, that is, it is determined by how much the least count of the measuring instrument is. That is, the smallest the least count, greater will be its precision. So precision means, it means the resolution, that means, or limit of it, you can say limit of which the quantity is measured. That is, how precisely you can measure the value. That is, the lesser the least count, that is, lesser will be the least count means the smallest count. Lesser the least count of an instrument, least count of an instrument, greater will be its precision. Greater is its precision. These are the two definitions of accuracy and precision. That means when you measure a physical quantity, you may be very much near or bit far from the actual value. That means you must have some error. So now what we have to know is error in such an instrument. That is, error in a measurement means how much inaccurate is your value. That is called an error. So error is equal to what? Error is actually equal to the difference between the true value and the measured value. It is the difference between the true value and the measured value. That is, suppose I tell you that you measured the temperature of a liquid and your temperature comes out to be 94 degree centigrade, whereas the actual reading is 96 degrees. So your measured value is 94 and actual value is 96 degree. That means the difference between the two is 2 degree. That means the error is 2 degree. So that is the meaning of error. Error in a measurement is nothing but difference between true value and measured value. Now these error may be different types. The different types of error. What are those different types of errors? So let us name them. Number one is constant error. Constant error. What do you mean by this constant error? The error which affects each observation by the same amount are called constant errors. That means uh, suppose you have a thermometer uh, giving you a temperature of 95 degree uh, temperature of a body when its temperature actually is suppose 90 degree. That means it is giving you an error of 5 degree. So when body's temperature is 90 degree, it measures 95 degree. That means when the body's temperature will be uh, 85, it will give you an error of reading of 90 degree. That means every time the temperature difference will be more by 5 degree. So such errors are called constant errors. Then comes number 2, systematic errors. You, since this is a video, you can write it down from the video by listening to it. Systematic, so I am not giving you the notes in written. Systematic error means the error which tends to occur in one direction. Either it is positive or negative. So such errors are called systematic errors. Now the systematic errors again can be, I mean, various types. That means it may be number one, systematic error may be due to instrumental error. Due to instrumental, it may be due to instrumental errors. Number one. Number two, it may be due to imperfection in experimental technique. Imperfection in experimental technique. I'll tell you what are the meaning of them. Technique, Technique. Number C, it may be due to personnel error. Number D, it may be due to external cause. Due to external cause. Now, what are the meaning of these four? Now, this systematic error, as I said, it tends to occur in only one direction, either positive or negative. Okay, they are called systematic error. Now, this may be instrumental. That is, some error may arise due to some defects in the instrument. So, it will systematically occur every time because of the defect in the instrument. So, that is called uh, instrumental error. And it may be due to imperfection. Suppose you are performing an experiment and you are measuring the temperature or length or whatsoever, but you are not very skilled in measuring. That means your technique is not correct. So due to this technical defect, you may have a faulty reading every time. So that will be called imperfection in experimental technique. Again, the next one may be due to personnel errors. That it may be due to the lack of proper setting of the apparatus by the person concerned, or maybe due to carelessness of the individual, or maybe some other eye defects. So these are all his personal causes due to which the reading may be faulty. And the fourth one is due to external cause. Sometimes what happens, the temperature, wind, etc. may affect the reading. Okay, so such readings are called errors due to external cause. Okay, so constant error, systematic error, and the third one we have is third error which we have is called random errors. So random, from the word itself, you know, it is called random errors. Random, from the word itself, you know, it occurs randomly, in irregular, in any magnitude and in any direction. It may be due to by chance, it may be due to slight variation in your attentiveness while taking the reading. Anyway, any side, any error in the reading will be called random error. Okay. Next one may be due to the least count error. Least count error means This error may be due to the error in the instrument. For example, the least count measured by a scale is 1 mm is meter scale. Okay, so its readings are good only up to this value. The error in the reading will be half of this value when suppose you want to have a meter scale of least count 1 mm. So its readings are only good up to this value. Now, if you have to read an length which is lesser than 1 millimeter, it will have some error. You will not have the accurate value. So that is called your least count error. And number fifth one is the gross error in or mistake. Gross error or mistakes. Now, what may be the cause of this gross error or mistake? These errors are due to either carelessness of the person or due to improper adjustment of the apparatus. No corrections can be applied for gross error. Now, abruptly, if you go on making mistakes every time while measuring the physical quantity, it may be due to your carelessness, you are doing in any direction your experiment, you are not using proper apparatus, you are not following any rule, you are careless. So there will be a gross error in the reading. So that cannot be corrected. So these are all the types of errors. Now there are three other errors which are very essential for measuring, and we will have to know how to calculate them. They are absolute errors, absolute, relative, and percentage error. Percentage error. Now, what is this absolute error? Now, I mean, how to, if you want to eliminate the error caused by randomness, that is, randomly you have calculated, then what you will do, you will take the mean of all the measured values of the physical quantities. So, that is, elimination of random error can be done by taking mean of all the values of the physical quantity. Then its true value will be given by the arithmetic mean of all. You will take many values and take their mean. You can remove the random error. But absolute error, what to do? The magnitude of difference between true value of the quantity measured and the individual measured value is called absolute error. So what do you mean by absolute error? The magnitude of the difference between the true value of the quantity measured and the individual measured value is called absolute error. So if we take the arithmetic mean, if you write, and then how will you express the absolute value? Suppose we write, let uh, let us write a bar as true value, a bar as true value, and a1 is the first reading. Okay, first reading. Then the absolute value or absolute error of individual measured values. That is each every a1 you have taken the first reading, and first the actual value, true value is this. Then absolute reading will be what? Difference between them. That is first readings, this will be a bar minus a1. Okay, suppose you have a2 as the second reading. Suppose you have a2 as the second reading, then absolute error of the second reading will be a bar minus a2. So likewise, if you take n readings, what will be the absolute error? It will be a bar minus a. So this is how we calculate absolute true value and individual measured value. Alright, this is what we are finding out. Now comes the mean of all these absolute values. How to find the mean? Suppose you want to find mean absolute error. Mean absolute error. How will you find? The mean absolute error will be written as mean of all the values you have taken just now. So if you have taken n number of absolute errors, then delta A1 plus delta A2 plus dot 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 plus delta an by n, that is equal to 1 by n summation of I equal to 1 to n absolute value of delta ai. That means you will take all the values and take their sum. So this will give you the mean. Okay, this will give you the mean. Then comes your third one, that is called relative error. So what is this relative error? The ratio of the mean absolute error to the true value. That is ratio of this, we have found mean absolute error. So mean absolute error, mean absolute error, ratio of the mean absolute error to the, to what? To the true value of the measured quantity, to the true value of the measured quantity. Okay, so this will become, here you have got delta A bar, so delta A bar divided by the true value, that is A bar. Now if you express this in percentage, it will be called the percentage error. You have to learn all this, then you have to, if you know the formula, you can easily calculate. Percentage error means if you are expressing this relative error in percentage, we call it percentage error. That is delta A bar by A into 100%. So this will be called your percentage error. So that will be all for today. So you go through all this for your next class so that we can easily do sums on them very easily. I hope it will be very clear. If not, you can pause and see again and again. Thank you.